Hello viewers, this is Wagda Ronald taking you through this tutorial for O-level mathematics. In this video we're going to look at multiplication of two matrices. So this video is best for students in senior 3 and senior 4. So when two matrices are multiplied together, the rows, that word, rows of the first matrix are respectively multiplied by the columns of the second matrix. So basically that is the only trick, that for the first matrix we are interested in rows, and for the second matrix we are interested in columns. So for example, if I have two matrices A and B, to multiply them, so also another thing to note is that the order must not be interchanged. If they say AB, it means that you start with A, which is that, followed by B, which is that. So if you interchange the two, the answers will not be the same, as we are going to see. So in this case, like we said, for the first matrix we are interested in rows, and second we are interested in columns. So for example, here if I deal with the first row and first column, I'll come up with A times E to come up with AE, then plus B times G to come up with BG. So that is how this value comes about. What about this value of AF and BH? How does it come about? So for that one, we shall consider first row and second column, whereby this times this will give you AF, which is that, and this times this will give you BH, which is that. So that is how this one comes about. Now what about this one? For that one we shall consider second row and first column, which is say that A times C will give you SC and D times G will give you DG. So note that it is always addition. So that has been this. What about this? So for that one, we shall consider first second row and second column, whereby C times F will give you CF and D times G times H will give you DH. Know that this is a plus. So that is AB, but like I told you, AB is different from BA. Therefore, if it was BA, then it would be in this form, and I think you realize that in this first part we are not getting something different from this, because this is the same but this is not the same, meaning that the whole of this value will be different. Similarly, for the second part, we are getting here it is AF plus BH, here it is EB plus FD, so they are also different. Then also for the third part, this is GA plus HC, this is CE plus DG, so they are also different. And lastly, for the third part, this is also GB plus HD, and this is FCF plus DH, so they are also different. So always remember that AB is different from BA. So when they give you matrices, always be keen on the order of the arrangement of the matrices. So basically that's the only knowledge behind multiplying two matrices, and now we shall use the knowledge to go through a number of examples so that you grasp the concept. So example 1 came from UNEB 1988, paper 1, question 10, and says, given that matrix A, which is that, and B, which is that, evaluate AB and BA. So we shall start with AB. So for AB we shall come up with that. So how does this come about? That is what we are going to look at. So for the first part, like we said, for the first matrix to consider rows and second matrix to consider columns. Therefore 2 times 2 will give you 4, and 3 times 1 times negative 1 will give you negative 3. So we have to add the 2. So 4 plus negative 3 is the same as 4 minus 3 to come up with 1. Then next we shall consider first row and second column, whereby 2 times negative 3 will give you negative 6, and 3 times 2 will give you 6. So when you add the 2, you get negative 6 plus 6, which will give you 0. Then next we shall consider second row and first column, whereby 1 times 2 will give you 2 and 2 times negative 1 will give you negative 2. Therefore 2 plus negative 2 is the same as 2 minus 2, which is 0. And lastly we shall consider second row second column, whereby 1 times negative 3 is negative 3 and 2 times 2 is positive 4. Therefore negative 3 plus 4 will give you positive 1, which is that. So basically that's how AB can be got. Now we shall go to BA. So for BA we have to interchange. B8 means that you start with B followed by A, therefore still the same procedure, row by column. So 2 times 2 will give you 4, negative 3 times 1 will give you negative 3, so in the end you'll come up with 1. Then in this case, next we will go to the next first row second column. So 2 times 3 will give you 6 and negative 3 times 2 will give you negative 6, so in the end we'll come up with 0, 1. So we'll come up with 0. So 6 minus 6 is 0. Then next we are going to second row first column, whereby negative 2 times 2 is negative 2 and 2 times 1 is positive 2, therefore you come up with 0. And lastly second row second column, so negative 1 times 3 will give you negative 3 and 2 times 2 will give you positive 4, so in the end you come up with 1. So it is a coincidence that both AB and BA are the same, but it's not a must that they will always be the same. So basically that's what they wanted, and now let's see how much can be awarded. So M1 will be for this multiplication and A1 for the output, M1 for this multiplication and A1 for the output. Now we shall go to example 2, which came from your NEB 1998 paper 2 question 6, and it says, given that matrices A and B, find AB minus BA. So in this case we are going to first get AB alone, then you also get BA alone, and after we shall subtract the 2. So for the first one we shall consider first row first column, so 2 times 2 to give you 2 and 2 times negative 1 to give you negative 2, so in the end you'll come up with 0. Then you consider first row and second column, so 1 times negative 1 to give you negative 1, 2 times 2 to give you 4, so in the end you'll come up with 3. The next shall consider second row and first column, which will be negative 2 times 2 to give you negative 4, 1 times negative 1 to give you negative 1, so in the end you come up with negative 5. And lastly we shall consider second row second column, whereby negative 2 times negative 2 is positive 2 and 1 times 2 is positive 2 still, so in the end you come up with 4. So that's how matrix AB can be got. What about BA? So BA still we shall follow the same procedure. Consider first row and first column, so 2 times 1 will give you 2 and negative 1 times negative 2 to give you positive 2, so in the end you will come up with positive 4. Then first row second column, 2 times 2 is equal to 4 and negative 1 times 1 will give you negative 1, so in the end you will come up with positive 3. The next is second row first column, so negative 1 times 1 will give you negative 1 and 2 times negative 2 will give you negative 4, so in the end you'll come up with negative 5. And lastly we shall consider second row second column, whereby negative 2 times 2 will give you negative 2 and 2 times 1 will give you positive 2, so in the end you'll come up with 0. So now we have got AB and we have got BA, but the question wants AB minus BA, so we shall come and subtract the 2. So BA is this and AB is this and BA is this. So when I subtract, I'll come up with, for example, 0 minus 4 will give you negative 4, 3 minus 3 will give you 0, negative 5 minus negative 5 will give me 0, and 4 minus 0 will give me 4. So basically that's what they wanted, and now let's see how much can be awarded. So B1 will be for this multiplication, and B1 will be for that, M1 will be for this subtraction, and A1 will be for the output. Now we shall go to example 3, which came from UNEB 2010 paper 1 question 8, and says, given that matrix P is equal to that, find P squared. So P squared means P times P, therefore we shall come here and say that P is that, therefore P squared will be P followed by P, and still we shall use the same procedure whereby first row, first column, so negative 5 times negative 5 will give you 25, which is this, and 6 times negative 2 will give you negative 12, which is that. So in the end, so next, that is how we get that this value. The next, for this value, it means that you said first row, second column, whereby negative 5 times 6 will give you negative 30, and positive 6 times 2 will give you positive 12. So that's how they get that value. The next, we shall consider second row, first column, whereby negative 2 times negative 10 will come up with this, and also 2 times negative 2 will come up with that. And lastly, second row, second column, so negative 2 times 6 to come up with this, and 2 times 2 to come up with that. So with that, we shall come and simplify our values. So 25 minus 12 is 13, negative 30 plus 12 is negative 18, 10 minus 4 is 6, and negative 12 plus 4 is negative 8. So basically that's what they wanted, and now let's see how much can be awarded. So M1 will be for substitution, and M1 was be for multiplication, both rows. So first row, that is M1, and also another row, that is another M1. Then A1 for the output. Then now we shall go to example 4. Example 4 came from UNEB 2007 paper 1 question 9, and says, given A equal to this, matrix A and matrix B, evaluate A plus B squared. So here what we shall do, we have to first add the two matrices, and after that we shall square them. So we shall come here and say that A plus B first will be equal to that. So 1 plus negative 1 is 0, 2 plus negative 2 is 0, 3 plus 0 is 3, 4 plus 1 is 5. Now that you have got AB, we can now come and square it and say AB squared is equal to AB followed by AB. So in that case, we shall come and say first row, first column, so 0 times 0 plus 0 times 3 to give you that. Then 0 times 0 plus 0 times 5 to give you that. Then 3 times 0 plus 5 times 3 to give you that. And lastly, 3 times 0 plus 5 times 5 to give you that. So that's how they multiply. Now next is to simplify to come up with 0, 0, 15, 25. So basically that's what they wanted, and now let's see how much can be awarded. So B1 for addition, M1 for substitution, M1 for multiplication, and A1 for output. So now we shall go to example 5, which says, which came from UNEB 2012 paper 1 question 12, and it says, given matrix P, which is that, Q, which is that, and R, which is that, find matrix T such that T is equal to P squared plus 3Q minus R. So here the first thing to do is to write the given equation and substitute. So P squared means P followed by P, so P times P gives you that. Then 3Q, so 3 is there and Q is there. Then minus R, so you bring this R and put it there. So the first thing to do is to do matrix multiplication for this part. So this is how it can be done. First of all, first row, first column, so 2 times 1 plus 2 times 4 to come up with this part. Then next is first row, second column, 1 times 1 plus 2 times 5 to come up with that. Then 4 times 1 plus 5 times 4 to come up with that. And lastly 4 times 2 plus 5 times 5 to come up with that. So that's how they multiply two matrices. So now that we have multiplied, next we'll be simplifying. So 1 plus 8 is 9, 2 plus 20 is 12, 4 plus 20 is 24, 8 plus 25 is 33. That is for this part. Now also for these two, they can also be subtracted. So negative 3 minus 4 will give you negative 7. Then 3 minus 6 is negative 3. 9 minus 10 is negative 1. 6 minus 15 is negative 9. So now that I've got these two matrices, next is to add the 2. So 9 plus negative 7 gives you 2. 12 plus negative 3 is 9. 24 plus negative 1 is 23. 33 plus negative 9 is 24. So basically that's what they wanted, and now let's see how much can be awarded. So M1 was B for substituting all these values for P, for Q, and for R. Then another M1 is B for this scalar multiplication, so to multiply this to come up with this, that is M1. Another one is B for matrix multiplication, so to multiply these two to come up with this, that is also another M1. The another M1 is for subtraction to come up with this, so to subtract these two matrices to come up with this, that is M1. And A1 is for the addition and output, so to add these two matrices to come up with this, that is also A1. So basically that's how the mass could be awarded. Now we shall go to example 6, which says given that matrix P is that and Q is that. So in this case P is a 2 by 3 matrix and Q is a 3 by 2 matrix, and R is equal to PQ. Determine the order of R, and part Roman 2, find the matrix R. So for you to determine the order of R, you have to first know the order of the given matrices. So P is 3 by 2, think you can see 2 rows, then 3 columns. For this one it is 3 rows and 2 columns, meaning it will be 3 times by 2. So from there, now for you to know the order of matrix R, compare this with this. So compare the first, so this with this. The smallest one is 2, so it will have 2 rows. Then for the columns, there is this 3 and this 2, meaning the smallest is 2, meaning our matrix R will be 2 by 2. So we shall come out here and conclude that R is a 2 by 2 matrix. So always look at the rows, compare the rows and take the smallest one, and also compare the columns and take the smallest one. That's how you can know the resultant matrix. So you can say R is a 2 by 2 matrix, or you can instead say that R is of order 2. So order 2 means 2 by 2, order 3 means 3 by 3, order 4 means 4 by 4. So in this case it is 2 by 2, so it will be of order 2. Now before I go to the next slide, let's see marks for this slide. So B1 for you to write the given orders of the given matrix, and another B1 for you to write the order of the required matrix. Now we shall go to part B, which says find matrix R. Remember R is PQ, so I have to multiply this with this. So I'll come here and say that R is equal to PQ, therefore I'll come and substitute for P and for Q. So this is P and this is Q. Okay, so next is to multiply. So when I multiply, I come up with that. So how did these values come about? Let's see. Remember, the rule remains the same. First matrix is consider rows, second matrix is consider columns. So in this case, this times this plus this times this plus this times this to come up with that. The next we shall consider first row, second column. So this times this plus this times this plus this times this to come up with that. Then also second row now, first column, so this times this plus this times this plus this times this to come up with that. And lastly, second row, second column, so this times this plus this times this plus this times this to come up with that. So after doing that, next we'll be simplifying. So when I simplify, this will give me 38, this will give me 14, this will give me 9, and this will give me 14. So basically that's what they wanted, and now let's see how much can be awarded. So M1 for substitution, another M1 for multiplication. So if the first row is correct, that is M1. If the second row is correct, that is also M1. Then A1 for output. So that brings us to the end of this video. Thank you for watching, and be reminded that next video will be on equality of two matrices. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on equality of matrices has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.